Good morning and welcome to today's Solving Puzzles with Python. Let's have a look at today's puzzle. So, puzzle number 17. Show how often each letter is used in a given phrase. For example, the elephant and the aardvark both thought the zebra was a loon. So we will have to find out which letters are used in the phrase and how often they are used. So loon has two O's in it, so we must recognise that there are two O's and another one here. And X doesn't appear in the phrase, so we don't want X to appear in our answer. I'm going to use Colab again, colabresearch.google.com, and I'm going to use matplotlib within Colab. So a couple of things to help explain the code. This is what we're going to end up with. So we're going to end up with a bar chart, and the letters that are used are along the bottom, and how often they're used is up the side on the y-axis. I'm going to produce two tables. I'm going to go through the phrase and produce two tables. One table, and this will eventually be the x-axis. One table records which letters are used. Okay, and notice they're all lowercase letters. There are 18 letters used, and this second list here again contains 18 elements, and this second list is how often they are used. So the T is used 6 times, the H is used 6 times, the E is used 6 times, the L is used twice, the P is only used once. Okay, and it's important that these two lists coincide. Now, this is done by use of index. So index runs from 0 to the end, so 0, 1, 2, 3, 4, 5, up to 17 because there's 18 elements. And so T is given the index value of 0, H is given the index value of 1, E is given the index value of 2. So the index value here is the same as the index value here. So it's the third, it's 0, 1, 2, the third element here, 0, 1, 2, the third element here. And by using the index value, we can keep these two lists accurate. So let's go over to Colab and see how we get on. So here's our sentence as it appears in the question, and I've put it into a variable called sentence to make it logical. I've got two empty lists here declared. One is called letter list, in which I will store the letters that are used, and another one called count, which will count each time a letter is used. This next block of code is a for loop for every element in the sentence, for every letter in the sentence. That's just a variable name, could be called anything, but letter keeps it logical. So this for loop will go through every letter in the sentence. Now, this next line here is an if statement. There's a few more if statements to come underneath this, and what this does is strip out anything from the sentence that occurs before the lowercase letters. I've done that to remove punctuation marks and non-printing characters and other things that we use, exclamation marks, speech marks, so on. And I am using the lowercase version of the letter, so even if it pulls the capital T, if it interrogates it capital T, then it will convert that to lowercase t. This continue will enable the program to jump out if this condition is met. Okay, so if the ASCII value of the letter we've pulled out of the sentence is lower than 97, then it will simply jump out at this point and not process it any further and go on to the next letter. Now this next block of code, else if statement, else if statement, looks at the letter list, and if the letter is already in the letter list, so we've come across the second E, so we've done THE there and we're onto the second E. Now if a letter is already in the list, then it determines the index number, the position of it within that list, and it increments the count list by 1. That will probably be more understandable when you see the next bit of code. So this is the final bit of code in the for loop. It's an else statement, so we've got an if, an else if, and an else. So if the letter is already in the list, then this bit of code fires. If it's not, so it's the first instance of finding the letter, then it will store that letter in the next available place on L list, on the letter list, and it will put a count, it'll put a 1 in the same position on the count list. So the first letter it's going to encounter is the T. So the T would normally be higher than the 97, it would be in the 60s, perhaps the 70s. So it would normally get stripped out, but we've converted it to the lowercase, so it's lowercase t, and that occurs 14, 15 places after 97, so into the 100 somewhere. So it'll pass through here. If it is already in the list, then do stuff here. Well, it's not already in the list. It's the first letter, the first time we've hit a T. So it'll go through here, it'll go through here, it'll get picked up by here. There's no if here, it's just an else. So the lowercase t will be added on to the letter list, and at the same spot in count, then a 1 will appear. So we'll get a T in L list and a 1 in count. If another T happens, if we get another T, then it'll get triggered by this block of code. We'll get this block of code, and it'll, via use of index, it'll realize where the T occurs, and at the same index point on count, it'll increment the value stored there by 1. If it's the first running, it'll already have a 1, so it'll add a 1 to it and get 2. If it's the third instance of the letter, there'll be a 2, and so it'll bring it up to 3. Now I've put a couple of print statements at the bottom so we can see what's going on. So we can print the letter list, we can print the length of the letter list, we can print the count list, and we can print the length of count. And there we have it. So there is every letter that's used, and there's 18 of them, and here are every account of every time it's used. there's only one S is only used once, W is only used once. So for example, these which only have a 1 in them, that is generated by this block of code here. If it's been incremented from a 1 to a 2 to a 3 and so on and so forth, that's been done by this block of code here. If it's an exclamation mark, it would have been stripped out by this bit here. Now with this, with these two lists, we can go on to create our graph. We've got this list here to provide the x-axis labels, and we've got this here, this list here to provide the values as shown on the y-axis. So back to the top of our code, we're going to import matplot here. Import matplot as PLT. It's easier to type in PLT than all this all the time. And we're going to use the style ggplot, which is a familiar style. There's many of these that you can use. ggplot is a nice simple one. And then we go into our code, the sentence blah blah blah. Now at the end of the code, I've got rid of the print statements that I showed you earlier, and here we create the bar graph here, plot bar. So we're going to plot a bar graph, PLT from there, PLT from here. So it invokes, by using PLT, it will invoke matplot library. So a bar chart with list as the x-axis labels and count as the data, and we're going to color it blue. X-axis labels, x-axis is going to be labeled the letters, the y-axis is going to be labeled frequency, and the whole bar chart is going to have the title use of letters. Use of letters would be a bit more graphic, and we want to display it obviously, plot show. Okay, let's run that, and there we have it. Use of letters, the T is used 6 times, H is used 6 times, A is used most frequently 8 times. And you can see that these letters here are only used once. So where might this be useful? Well, if you're going to run a compression algorithm, if you compress the S's, the W's and the B's on a block of text, and on this block of text anyway, it's not going to reduce the volume, it's not going to compress the file by much. But if you can somehow compress all the A's and the E's and the H's and the T's, then that will make the file quite a bit smaller. If you could only use 1 character for the A instead of say 8 characters, then that will make a big reduction on the size of the file, and the same for the THE. Where you could also use this is if you're trying to decrypt a piece of text that has been encrypted in the substitution routine. So if the A's had been replaced by a Z in this code, in an encrypted bit of text, then by seeing how often this symbol appears, you'd be able to determine that possibly then that is a letter A. So regardless of what it says here, if the most popular letter used in a bit of text could well be an A, the second and the third most popular letters used in a bit of text could be a T or an E, and so on with these popularity ratings. And using a popularity rating enables you to crack code, decrypt something that has been used or that has been encrypted with the substitution routine. Anyway, that's it for today's puzzle. See you next time on Solving Puzzles with Python.